Okay, so finding the slope of a function is basically the same thing as asking you to take the derivative of the function at a certain value. So we just take our derivative, y prime is 2x plus 6, and when x is negative 2, the derivative when x is negative 2 is 2 times negative 2 plus 6. So that's negative 4 plus 6, so the slope should be 2. And we can see that if we look at our graph, when the x is negative 2, when we come to, oh, that's negative 4. Let's try again. When x is negative 2, the y value is down here, and then the slope of this line should be 2, the tangent line. So if I go up 2 and over 1, up 2 and over 1, down 2 and over 1, I create this line, and that line is tangent to the graph, and that slope is 2 there. Had they asked me at different points, had they asked me to plug in when x was, say, negative 3, the slope would have been 0 because the tangent line is 0 there, and you can see 2 times negative 3 plus 6 is indeed 0, and you could find it at different points, so the slope here would certainly be negative, and so on. All right, let's do it again. So again, we want to find the slope, so we're going to take our derivative. So y prime is 3x squared minus 6x. So when x is 3, y prime is 3 times 3 squared minus 6 times 3 is 9. 27 minus 18 is 9. So your slope is 9. So when we go to x is 1, 2, 3, we look at this point on the graph, and we can see that the slope of this tangent line will be very steep and positive. So 9 is very steep and positive. If you want to play with other values, if you plugged in a 2 for the x, you should get 0, because you can tell your tangent line, your slope of the tangent line is 0 here. Also, when you plug in a 0, you get 3 times 0 minus 0. For anything you plug in between 0 and 2, you should get negative numbers because the slope is going down. So play with it. This is going to give you the slope of this curve at any point. But for the one they want, when x was 3, the slope was 9. All right, so here they don't give you the graph anymore, which I kind of liked the graph because that made it very visual, but now we're just taking the derivative and plugging in stuff. So when x is 2, y prime is going to be 3 times 2 squared minus 12 plus 9. Oops, I lost the x. 12 times 2. So that's 12 minus 24 plus 9. Negative 12 minus 9 is negative 21. All right, and again. So y prime is negative 3x squared minus 12x minus 9. When x is negative 4, we have negative 3 times negative 4 squared minus 12 times negative 4 minus 9. So 16 times negative 3 is negative 48, plus 48 minus 9 should give me minus 9. Let's see. So now we use quotient rule. So I'm going to just put this negative 1 up at the top. So I'm going to do that. And so the derivative of the top is 0, and then it doesn't even matter what the bottom is. And then I subtract the top times the derivative of the bottom, square the bottom, and off we go. So when x is negative 2, I'm going to get 2 times 2 is 4 on the top, and then 4 minus 9 squared, so that'll be 4 over 25. Another quotient rule. I'm going to put this negative up on the top to make it just a bit easier. So I have the derivative of the top is just 0, and so it doesn't matter what the bottom is. So I subtract the top times the derivative of the bottom, square the bottom, and off we go. And then we have 3 on the top when x is 1, and then 1 plus 5 squared, so that'll be 3 over 36, so 1 over 12. All right, a little bit of chain rule now. So multiply by the 1/3, subtract 1 from the power, leaving the inside the same, multiplying by the derivative of the inside, but here it's just a 1, so it doesn't matter. When x is negative 1, we'll have negative 1/3 times negative 1 plus 2 to the negative 2/3, which is just, this is just 1, so 1 to the negative 2/3 is just 1. So negative 1/3 times 1 is just negative 1/3. And another chain rule. So we multiply by the 1/2, so negative 1/2. Keep the inside the same, subtract 1 from the power, times the derivative of the inside. So when x is negative 5, I'll have negative 1/2 times 5 plus 2 to the negative 1/2, and that negative will make this positive. And so this is going to be 1 over 2, and the square root of 7 will go on the bottom, because the 1/2 makes it the square root, the negative puts it on the bottom. And if I rationalize this, I get the square root of 7 over 2 times 7, so the square root of 7 over 14. All right. Let's see. So now derivative of the ln. So that's just, the negative's not concerning us. We'll just throw that negative times the derivative. So the derivative of an ln is 1 over what's ever inside times the derivative of the inside. So when x is negative 3, I have 1 over, it'll end up being a positive 1, because that and that. And 3 plus 2 is 5. All right. And then another chain rule. So the derivative of sine is cosine. Leave the inside the same and multiply by the derivative of the inside. So when x is negative pi, we'll have the cosine of negative 2 pi times 2. So the x value at negative 2 pi, if we go backwards 2 pi, the x value there is 1. So we have 1 times 2, just a 2. All right, that should do it.